Greetings everyone. Welcome to Kite lecture series. Today we will be discussing about cloud usage scenarios part 2. So in previous video we have studied about the history of cloud computing, evolution of cloud computing and some basic terminologies of cloud computing. Today we will be discussing about major players in cloud computing, business models around cloud computing and underlying principles of distributed and parallel computing. So let's start. So before moving on to the major players of cloud computing, we would be first knowing about the business models around cloud computing. So in cloud computing, if we are talking about cloud computing and we have talked about that it's a buzzword, so we have an idea that there must be some fair business about it. So in this section we would be discussing various business model which is revolving around cloud. See, when I say business model and when I say service model, both are the same thing, so you don't have to be confused. You don't have to get confused. Business model, service model are one of the same thing, right? We would study this thing in detail in our next videos, but right now let's have an overview. What is exactly the business model? So basically we have segregated cloud business models into three different parts. First is infrastructure as a service, second is platform as a service, and third is software as a service. So basically major companies like Google, Facebook, which are into this cloud business, right? They provide different services to cloud users, and based on the type of service they are providing, they have segregated their business model, right? So that's why business model and service model are one of the same thing. Now if we talk about infrastructure as a service, in this what they do is they provide basic computational resources to the customer on a virtual level. Basically they provide an interface where users can manage all their computing resource. And when I say computing resource, it means networking, it means storage, it means your computation power. So in infrastructure as a service, user has an interface where they can virtually control the storage, networking and computation part, right? They're basically providing all the authority to the users where they can control their computing resources. Okay. And the example of infrastructure services are Microsoft Azure, AWS, GogGrid, Rackspace, CloudWard, Numerology, OVH. Basically these are the companies which provide infrastructure as a service. Okay. Next we move on to platform as a service. Now see, platform as a service, what do you mean by platform? First, platform is a kind of an interface where you in computer science, platform can be regarded as all those software tools and all those hardware and software tools which could be used for application development. This business model, the platform as a service, is generally used by web developers, or you can say application developers, where you need a hardware to develop on which your application could be developed, but you don't have that. So what they do is they provide you a platform, and that platform can be some different business tools. The platform includes operating system. Platform may include a kind of IDE, integrated development environment. All these things comes as platform as a service, and the companies that provide platform as service are Google App Engine, Force.com, Microsoft Azure, Gaudi Process Factory. So we have talked about Force.com earlier, that it was the first website who delivered the software via internet, and Google App Engine is the latest buzzword. You can create your app on Google App Engine. Microsoft Azure is also an infrastructure as a service, and it's also a platform as a service. And in this case, Microsoft Azure is providing their operating system so that people can have their application and they can develop their application on Microsoft Azure. And same is with the Cordy Process Factory. So this was your platform as a service. Now let's talk about software as a service. In software-based services, softwares, or you can say applications, are deployed over internet, and you can use their application on their websites. In software as a service, you can control the application via web portal, right? You can control the functionality of the web, that application which is being hosted on that web portal. And the best part is the abstraction. You don't know on what platform it is made. You don't know what type of hardware is behind it. So there is an abstraction. So as you are moving upward, there is a kind of abstraction, or you can say there is and when there is an abstraction, there is a simplicity. It means that on software as a services, for example, I am using this PPT, right? And this PPT is made on Prezi.com. Now I really don't know on what operating system it is based, right? So as we are moving upward, the abstraction is getting increased and simplicity is getting increased. Example of software as a services are applications, web services such as Facebook, Google Apps, Salesforce, YouTube, Prezi, right? Now let's talk about what are the big industries which are involved in cloud technology. Microsoft Web Services, you all know about it. Microsoft Web Services provide infrastructure as a service. Microsoft Azure primarily provide platform as a service. Now it is providing infrastructure as a service as well. Google Cloud Platform provides both infrastructure as a services and platform as a services, and also a software as a services, right? So Google Cloud Platform is something which provides IaaS, PaaS, SaaS. Through Google Apps, you are accessing their software. So they are providing software as a service through Google Apps. Now, through Google App Engine, they are providing platform as a service. Okay. Now, Adobe Creative Cloud is a software as a service application where you can edit your pictures, and Google Creative Cloud helps you in editing your pictures. And apart from that, VMware, IBM Cloud, Rackspace, Red Hat, all these are some major companies which are involved in cloud computing. Now let's talk about some underlying principles of parallel and distributed computing. Let's talk about distributed computing first. Okay, in distributed computing, let's say what they're saying. In distributed computing, networks of autonomous systems that communicate with each other to achieve a common goal. Okay, computers in distributed system are independent and don't physically share memory and processor. They communicate with each other via message passing. So there are 3 points. First, that all nodes which are involved in distributed system are autonomous in nature. Means they have their own task and they can come together to share a common task, to share a common problem. This thing I have already discussed when I was giving you the example of Avengers in previous video. So there's nothing much to discuss about it at this stage. Now, computers in distributed computing are independent and don't physically share memory and processor. Yes, they don't physically share memory and processor, and they communicate with each other via message passing. Yes, they communicate with each other via message passing. They have certain protocols where they pass the message, and with those protocols, communication is being established. Now, types of distributed system: client-server computing and peer-to-peer computing. See, previously, I just want to clear one thing. When I was talking about the history of cloud computing, I told that initially it was client-server architecture. Then they developed a distributed system, and after that, distributed system become a broader term, because after that distributed system contains both type of architectures, client server computing or peer-to-peer computing. They both come under distributed computer. But when we talk about distributed system in general, distributed system is a decentralized approach in general. But if you talk about types of distributed system, then this client server computing and peer-to-peer computing both are the part of distributed system. Now here in client server architecture, client requests a resource and server provides that resource. Now this is a type of centralized situation where there is a master and there is a client, and a client is requesting certain thing from the server or a master, and based on the request, first they have to grant the access of the resource and then they will provide that resource, right? So this is the system of client server computing. And in client server computing, server may serve multiple clients at same time while client is in contact with one server. Obviously if we say that if we take an example of Facebook, you are a client, your system is a client, or your mobile is a client, and you are contacting with the Facebook server, and based on your request, Facebook is first authorizing you as a server, then giving you the proper resources, that your feeds that you are missing, that feeds that you want, right? And after that, it can be possible that many users may be logging to that Facebook server at same point of time, and they are serving multiple requests. But obviously you are requesting with one server. Now coming to the next point, both client and server are usually communicate via computer network, so they are a part of distributed system. Obviously they are the part of distributed system when they are communicating through a network. And as you can see, it is a centralized approach. We have already discussed it later. There is nothing much to discuss. Let's talk about peer-to-peer computing. Now peer-to-peer computing is something that we have already discussed when we were discussing about grid computing, right? Grid computing is an example of peer-to-peer computing where every participant or every node is having an equal preference. No one is the king, no one is the master in this system, and there is no one system who is taking all the data. Every system is having some chunks of data, and they all share their data and resources with each other to complete a particular task. Here, as you can see in the second point, all tasks are equally divided between all the nodes, and nodes interact with each other as required to share resources. This is done with the help of a network. Yes, they all share their resources and everybody is having equal participation in data sharing, right? So this is a decentralized approach. Now both are having their disadvantages. In centralized approach, if we talk about the disadvantages, the main disadvantages is that the centralization of power. All your data is being stored in one computer or one server. Now if that one server is get destroyed, then your whole system would be shattered. But in decentralized approach, even if you destroy one of the node, then your whole system will still survive. Only that part of data won't be available for backup. Otherwise you will still have majority of data, because here every system is having some kind of data, and it might be possible that the copy of data has been stored in some other node as well. So even if you destroyed one node, it might be possible that you can back up the data from some other node. This type of system is generally used in military applications as well, where a grid of computers and nodes were there, and they make network in such a way that even destroying one of the node won't affect the entire system. Okay, now this is the disadvantage the generalized advantage and disadvantage of distributed system. When we talk about generalized advantage and disadvantage of distributed system, now they consider distributed system as a group of autonomous computer which are combined to solve a problem, and they can share data with each other. So first advantage is nodes can easily share data with other nodes. Yes, we can easily share the data. More nodes can easily be added to the distributed system, that is, it can be scaled as when required. So as you can see, in distributed system, uh, the flexibility in scaling the system is very good. I mean, if I'm having a system, suppose I'm having a firm which requires the operation of 10 computers. Suddenly I want 200 computers, so I can easily scale it up in cloud computing. The failure of one node doesn't lead to the failure to the entire distributed system. Others node can still communicate with each other. Yes, failure to one node won't destroy and the entire system. Other nodes can still communicate. Yes. Now resources like printer can be shared with multiple nodes rather than being restricted to just one. This is now these are the advantages. Now let's talk about disadvantages. In disadvantage, it is said that it is difficult to provide adequate security in distributed system because the nodes as well as the connections need to be secured. Now in distributed system, there are nodes and there are high performance interconnects, or I would say there are some networks which are providing communication. Now we need to secure both of them. First is the node and second is the network, because if you are sending data from A to B location, there are chances that that data can be exploited in eavesdropping. Second is some messages and data can be lost in network while moving from one node to another. This is a general disadvantage of networking. See, if you are using networking, it can be possible that some of your packets may be lost, some of your packets may not be lost. So this is something which is an issue of a network. Next is database connected to the distributed system is quite complicated and difficult to handle as compared to a single user system. Obviously, it is easy to install SQL in my local system rather than sharing it over a distributed system where any node which is connected with my system can manipulate in my database. So it's quite complicating. And the fourth point is overloading may occur in network if all the nodes in distributed system try to send data at once. In distributed system, we have a network, right? And network may lead to congestion. If every node is sending the data, then there would be a bottleneck where there will be message overloading. There would be a congestion, and it might be possible that you might not receive all data. Now let's talk about some basics of parallel computing. Now when we talk about parallel computing, so in parallel computing, it is the use of multiple processing elements simultaneously for solving any problem. Problems are broken down into instructions and are solved concurrently as each resource which have been applied to work is working at same time. So as far as parallel computing is concerned, it is very much different from your SQL computing. Till now, whatever programming that you have done is a sequential kind of a programming. You have no idea about parallel programming, parallel computing. I'll give you an example that will clear you about parallel programming and parallel computing. Suppose you have made a program, and that program contains three functions: function A, function B, function C. You have made a sequential program where you have created a program in such a way where flow of program goes like, first it will execute program A, second it will execute program B, and third it will execute program C. Now on further analysis, we realize that we can optimize this process by analyzing the fact that A and B are those functions whose values are dependent on each other. I mean, A and B are those functions where if the output of A would be served as an input of B, and then it will produce its own output. So here A and B are dependent on each other, but we realize that C is that kind of a function which is independent, which is an autonomous function. It don't need C don't need A and B. C is that kind of a function which can run parallelly at same point of time when A is running or when B is running. So what we do is we divide the program into two chunks and then feed it parallelly with your two processor. You might be having a dual core processor. When we talk about dual core processor, it means that CPU is having two cores. It means they are having two computing units. So at same point of time we would be dividing the task, and in that program A would be divided into two parts, and then function C is being fed on one processor, and simultaneously function A and B is being fed on other processor. So in this case you will realize that problems are broken down into instruction and are solved concurrently as each resource have been applied to work is working at same time. Okay, so here you can see this one is the sequential problem, and we have just divided the task and we have fed it to two different processors simultaneously. So let's see some of the advantages. It saves time and money. Yes, it saves time. Your time is getting reduced. When we talk about time, we talk about money. Time is money, right? So let's talk about the second point. It is impractical to solve large problem on serial computing. Okay, I got an example for you. In 1990s, a research was going on based on mapping the genome. Genome is a part of an DNA. Basically, it's the structure of DNA, right? And when the first genome was mapped, it took 13 years. It literally took 13 years to map it on a computer. And that computer was obviously, it was a sequential computer. And next time when they used parallel computing technologies based on cloud, which is backed by cloud computing, all these are the concepts of cloud computing, right? So using parallel computing, it took less than an year to solve that problem. At this point of time, you can map your genome of your family within certain days, and this achievement is phenomenal, and this is all because of parallel computing. Let's talk about our third point. It takes advantages of non-local resources when local resources are finite. When you have finite local resources, then obviously it takes the advantage of non-local resources. It is saying in this context, suppose let's take an example of that program where I talked about three functions A, B and C. Now this whole program would be fed to one processor. That processor would be a local processor and another processor would be a non-local processor. Now, and they are saying that it will take the advantage of that non-local resource, the other resource. They are talking about the other processor where local sources are finite. Here we are feeding this program to one resource, and we can exploit the usage of other resource as well. Serial computing wastes the potential computing power, thus parallel computing makes it better work of hardware. Serial computing wasted the potential computing power. This point is very much valid because it may be possible that suppose I am reading this presentation and this program is being run, I am recording this video on OBS, right? And for processing the input values and output values of OBS, maybe I'm having quad core processor. Only one of my processor is being used. Other processor may be using some different task, or it might be possible that one of my processor which may be idle, right? So this is an excellent example where you can exploit full power of all the resources. Now no resource would be idle in parallel computing, so it makes better work of hardware. So that's all about parallel computing. these are the underlying principles of parallel and distributed computing. So in this video of cloud scenarios, we have discussed about history and evolution of cloud, major players of cloud computing, business model of cloud, and underlying principles of parallel and distributed computing. That's all for today, guys. Thank you so much. We will discuss more in next upcoming videos. Till then, take care of yourself, and to all of us I say, greatness is coming. Jai Hind.